Okay, so in this video, I'm going to do two examples of volume using cylindrical shells. I'll just get right into the example. So what I want to do is I want to use this region bounded by the curves, so y equals 2x, y equals 0, x equals 3. So the first time I'm going to do this for the volume generated by revolving around x equals -1, and then the second time it'll be revolving around y equals -2. So we can compare like how the approach differs, okay? So of course you cannot do anything until you know what you are working with here. So let's go ahead and sketch this out. So let's see. Here's my x equals -1, just so I have that reference. And then let's see, 1, 2, 3, 4. Okay. So I've got 0, 0. Here's 3, 6. Here's my curve, y equals 2x. So I have x equals 3 and y equals 0. So here's the region that we're talking about. And I'm going to revolve this way, right? So I think it's always nice just to have a little sketch of what it is that you're looking at. So let's see, here's my line, here's my curve, here's kind of the reflection of that curve. So I've got like this giant thing with a hole, right? There's like this big hole in the center. So this is like a big old hole around it. Okay, anyways, so with this rotation, so when you rotate around a vertical line, you're going to integrate with respect to x. So in this case, I'm going to use kind of this formula. Let's see, where, let's see, shell height, and then dx. Okay, so I'm integrating with respect to x. I need to know what my shell radius is and my shell height. Now, in general, your shell radius can just be found by x minus whatever line you're rotating around. And let's see, we also know that we're integrating here from 0 to 3, so I can plug that in. Okay, so I'm rotating around the line -1, so this will be x minus -1. And then this shell height, so that's really being entirely dictated by this curve here. So it's got a flat bottom, and then just this curve, which is 2x, is dictating the height. So I can just plug that in, so 2x. So there's everything for this integral, so I can make some space. And so then we just integrate, so I can bring the 2 pi out, and I'm really integrating 2x squared plus 2x. And so let's go ahead and integrate. So let's see, this will leave me with 2/3 x to the third plus x squared from 0 to 3. The 2 drops out because I'm multiplying 2 times 1/2. So here's what I've got. So let's see, this will be 2 pi 2/3 times 27 plus 9, all of that minus 0. So let's see, that'll be 2 pi 18 plus 9, so that's 2 times 27, 54 pi is what I get. Okay, so now let's contrast that to rotating the same curve around the line y equals -2. Okay, so same sketch. And let's see, y equals -2 is going to be this line here. So now I just want to rotate this way. So I'm just going to try to sketch something kind of small. So here's my, let's see if I can sketch this. So here's my axis, here's my line. So I have something going here. And then I'm going to have something, let's see, going here. All right, so we've still got a big hole in this thing, right? So I've got this Now my object's going this way with a big hole in it again. Okay, now, since I'm rotating around a horizontal axis, that's going to flip my formula. And maybe instead of using AB, so I've got to find new limits of integration, so I'll call it CD. So it's still going to be the shell radius. And so I guess we could call this like shell width or shell height, depending on how you're thinking about this. So maybe what I'll say is, I'll say this is what I mean by height. This line here is what I'm talking about, so this shell height. But since I'm rotating now around a horizontal axis, this whole thing's now going to be in terms of dy, so in terms of y. Okay, so to figure out what my shell radius is this time, actually, okay, so this is going, by the way, from now 0 to this point here is the point 3, 6. So now I'm going from 0 to 6 because I'm converting everything in terms of y. Okay, so for my shell radius, so now it's going to be whatever my y is minus where my horizontal line is. So in this case, it's going to be y minus -2. And then, okay, so this, I call it height still, width, whatever we want to call it. The length of this, how do I measure this depending on kind of where we're at? So I guess width would be better. Well, this now is still actually being dictated by this curve. However, so the way I kind of help myself wrap my head around this, so now this length, depending on where I am in the curve, so if I maybe draw here, so let me get rid of the color here. Okay, so what are these different lengths that I'm drawing here? How would I model that? Well, it's this, right, minus this curve. But I need everything in terms of y. So now, instead of this being y equals 2x, we're going to call this x equals y over 2. So I can divide this function here by 2. So now I'm going to call this x equals y over 2. So it's really going to be 3 minus this curve, and that's what's going to get me these lengths. And again, the way I figured that out, here's where it starts, here's where it ends. I always go from right to left, and this curve here is dictated by this y over 2. So that's going to be my height, my width, however you want to think about it. So 3 minus y over 2. Okay, and so now we're off to the races. We've got everything we need. So let's make some space. And I like this example because I think it really demonstrates like how different, you know, a small change like rotating around a different line can change the problem. Okay, so let's do this. So I'll bring 2 pi out. I've got 3y minus y plus 1/2, or sorry, minus 1/2 y squared. Let's see. Oh, and then plus 6. Okay, so there's everything. So I can simplify all of this before I integrate. I'll call this 2y minus 1/2 y squared plus 6 dy. Okay, and so now we can integrate. So I'll just fast forward through this part so that you can see my work, but I don't have to make the video so long. And so what I got is all of this worked out to 72 pi, and you can see my work, so you can pause the video if you'd like. Okay, and so that covers this video, so hopefully that was helpful. Got any questions, you can always leave them in the comments, and I will check you guys in the next video.